So hey guys, welcome back to the day 8 and today we're going to discuss about the binary search and the linear search. So these two methods are very much important when it comes to interview preparations, and when we're targeting some sort of greatest companies, then binary search and linear search plays a very major role in the company placements. Okay, so today we're going to discuss about that both searching methods, and in day 9 we will solve some sort of binary search problems. Okay, so keeping our tradition to solve some of the finest problem on the competitive platform, we have brought you a binary search problem today. But before that, now we will first understand what the search is. So when we talk about searching an element, so you can take an example that like I have given an array. Okay, there is a simple array I am given like this. I have given an array, and let us suppose I just want to find 3 in this array. Okay, so what was your first approach of finding 3? Talking about, if you don't know anything about binary search and linear search right now, just focus on finding the element 3. So I want that you should focus on finding element 3. How you can find this element 3? So the things which you can do is you can start over from here and you can check whether 1 is 3. No, it's not 3. Either 2 is 3. No, it's also not 3. This is 3. Yes, this is 3. So I will just return the index, which is 2. Talking about the index, so 0, 1, 2, 3, 4. Like this we do the indexing, so I am returning the index that at second position of this array 3 belongs. So this is the very simple searching method which we have done. So why we are just going on to different searching methods? Why we can't do from one only? The thing is, like, let us suppose of a case when I have this array and I want to search 8 in it. So first I will match from here. It will not, then it will not, again 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 then it will be. So how much comparison I have done? I have done 8 comparisons here. So you are noticing, like, when in the worst case scenario, like this is the worst case scenario, and in this scenario you can notice one thing, that my 8 is at the end of this array. Okay, so my 8 is at the end of the array. So in that particular cases, my time complexity will increase drastically. Okay, so right now when we talk about this particular searching method which you are doing, this searching method is termed as linear search. Okay, this is called as linear search. Very easy. So the time complexity here, like if I consider like there till n this array is, okay, let us suppose like till n. Okay, let me take like till 1 to n you are having the numbers, and I want to search nth number. So I will have to make n comparisons. So my time complexity big O of n. Clear? Now I hope this thing is clear to you. Okay, so this is the basic searching method which you have just done. Now let us implement this thing. This is the linear search. Okay, so in Python how you can do it? Very easily you can perform it. How? Like you can just write a simple code for that, and let me erase this particular stuff. In Python you can do it in no time, guys. In no time, like you have to just declare one target. Okay, you have to just declare one target. Let me suppose your target is 9 and your array is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so for I in array, if I is equal to target, then we have to just return the I. So this is the very simple implementation of a linear search. Okay, like this we are doing the searching. Let's go and let's implement this thing in Python. So now I think the screen is visible to you, so we will just implement this thing in the Python, guys. So here I will define one target. Let us take an example, like this is the target like 9, and I am creating one array in which the elements are like 1, 2, 3, 4, 5, 6, 7, 8, 9. So I will write for I in array, if I is equal to the target, then you have to just return the I. So like if this is the function, I can write like this, but I will do like this here. Okay, very much simple. And when I will run this, so it is returning me at 9th. Okay, like this, that my 9 is getting returned. It means that it is in the array. Okay, so now if you want to return the index, how you can return the index of it, simply what you can do like this, you can run a loop for I in range 0 till length of this array, correct. If array of I is equal to the target, then what you can return, just return the I, or you can print the I. So it will return you the index. So for returning the index, you have to write like this, and let's see how it will be printed. Simple. So 8 is printed. It means that at 8th index your I is there, or your 9 is there. So this is the basic searching which you have just done. It's a linear search. Okay, so now let's go to the binary search again, and let's understand this problem. Okay, so why we need binary search? So the things which you should remember when it comes to binary search. Okay, so it's very important, guys, to remember these particular stuffs when it comes to binary search. It is a very easy problem. It's a very easy problem to be solved. But what is the need? What is the need actually of solving this problem? What is the need? Okay, so firstly, if I talk about this array only, binary search always run on the sorted array. This you should remember. Your binary search will always run on the sorted array. It means that your array should be sorted before it gets run. So what is the reason behind the binary search is, let us suppose I want to search 7 here. Okay, let us search, I want to search the 7 here. I want to search 7 here. Now remember one thing. In the linear search, I am searching like this, one by one to every element. But now in the binary search, what I will be doing? In the binary search, first I will have one start pointer, which we can take it as a low, and I will have one high pointer, and I will first find mid pointer. So in this case, let's suppose is my high is at 0, 1, 2, 3, 4, 5, 6. So 6 plus 0 by 2, which is 3. So it means my mid pointer will be at here. Okay, simple. Till now you have understood basically what is the reason. Like instead of searching this complete array, we will just break this array into our interest. Like as we know that now here I am having my mid. How I have calculated a mid? I have declared. Now just remember the steps. Okay, you have declared one start pointer, you have declared one high pointer. Start is focusing on the start of your array, and high is focusing on the end of your array, and then we are calculating the mid. Okay, what is the mid? Mid is the sum of high plus start divided by 2. Now your high is not this element, your start is not this element. They are their indexes. Okay, your start is index and your high is also index. Like here it is 6, here it is 0. So 0 plus 6, 3. So here my mid pointer will be. Now what I will do? Now my target is 7. As I previously mentioned also, my target is 7. So what I will be doing? I will just match with this mid. Okay, so the element which is at mid is 4. So is my 4 is equal to 7? No. Is my 4 is greater than 7? No. Is my 4 is lesser than 7? Yes, my 4 is lesser than 7. Then instead of searching in this array, what I will be doing, I will shift this mid pointer. Okay, not this mid pointer. I will shift this start or low pointer to the here, or mid plus 1. Got my point? Basically the logic is like, instead of searching the complete array, we will only search the half of the array. Okay, we will only search the half of the array to get our answer. Like this, it's very much common. Like if this array is sorted, and if my mid value is lesser than the target, then what I have to do? Remember these lines, like if my mid value is lesser than the target, then you have to just change your low pointer to mid plus 1. Easy guys. Now what will happen? Now what will be the case? Now you will see that my start pointer is here. Now again I will be calculating the mid. Okay, how I will calculate the mid? Like right now my start is at 4 and my high is at 6. So 6 plus 4 divided by 2. So it will be giving me the 5. So it means my mid pointer will be here. Like 5 is written over here, so my mid pointer will be over here. Again I will compare like whether my mid value which is 6 is greater than 7, or my mid value is lesser than 7. So you will notice that it is lesser than 7. So again what I have to do? This start will come over here where the high is, and then we will be comparing again. Now if I will find the mid, now my start is over here. Now my start and high is on the same point, which is 6. So now I will again find the mid value, which is 6 plus 6 by 2, which is will be returning the 6. And then I will compare, like if this value is equal to my target, yes. So what I will do? I will be returning its index, which is 6. So how many comparisons we have made here? How we have comparisons in here we have made this one comparison, here one comparison. Okay, then we have made here one comparison, and then we have made here one comparison. So you are seeing this stuff. So in only 3 comparisons we have got our answer. Easy. So in the 3 comparisons I am getting my answer. Isn't that great? Isn't that this thing is great? So instead of searching it, I am getting my answer. Okay, instead of searching this completely, I am getting my answer easily. So if we go to the linear search, and in the linear search I want to do the comparisons like one by one. So there will be 7 comparisons in total. But when I talk about the binary search, so in the binary search I have only made 3 comparisons to get my answer. So this thing is great. I am getting my answer in less than this time. Okay, less than half of the time even. Okay, so this particular thing, this is the basic crux of a binary search. Okay, I hope you just understood what the binary search is and how it works. Now let's take a case. This is your array. Your start is here, your end is here. Let me change the name so that you can even remember it, because this terminology, your low is here and your high is here. Talking about the indexes, then they are 0, 1, 2, 3, 4, 5 and 6. Now if I want to search 1, in this array, then how I can do it? Now again I will find the mid. So when I will find the mid, then what it will be? Low plus high by 2. So my low is at 0, so 0 plus, and my high is at 6 by 2, which will be returning 3. So here will be my mid. Now what I will be doing? I will be comparing this mid with the target. So this is my target. So this is the first step which I have done. Again what I will be doing? I will be comparing with the target. So here you will notice that my target is lesser than mid. Now if this is the case, if my target is lesser than mid, like in the previous case my target is greater than mid. So in this particular case what I will be doing, instead of shifting the low, I will be shifting the high, and my high will be changed to mid minus 1. Okay, so my high will move here, my high will be moving here, and then what I will be doing, simply guys, what I will be doing, again what I will be doing, comparing, again I will be finding the mid. So again my mid will be low plus high divided by 2, and this thing should be returning me is 0 plus 2 by 2, which is 1. So right now my mid will be here. Okay, correct. And then I will be comparing this thing again with the target. Fourth step, again the target will be compared. So in this particular case, you will remember that my target is again lesser than mid. Then what I will be doing, again I will be shifting my high to mid minus 1. So it means my high will move over here in this case. Now they both are on the same thing. So again when I will be comparing the mid, it will be low plus high by 2, which will be equal to 0 plus 0 by 2, which will be returning the 0. So at particular thing, now again I will be comparing, like, is my mid is now equal to target, or any other case is possible. So if this thing is happening, what I will be doing, I will be returning the mid. So now you are just seeing that I have just written this complete logic over here in this particular case. Let us suppose I want to search 4 over here, then at that first particular case I will get my answer. Okay, so this is the basic approach of a binary search. Now I think you have just understood this thing. So what you have to remember, you have to remember 2 to 3 things. Like, you have to keep on searching, you have to do on searching till your low is lesser than equal to your high. That's point number 1. And next thing, whenever your target value gets lesser than mid, whenever your target's value get lesser than mid, then what you have to do, if your target is lesser than mid, then you have to shift your high pointer to mid minus 1. Okay, and when your target value gets greater to the mid, then what you have to do, then you have to shift your low pointer to mid plus 1. That's a very simple logic, guys, and you can understand it in no time. Okay, now let's code it over and let's see how we can get the solution. So now we will just go to the, let's go. So now I will be going to the Leetcode directly for the code. Okay, you guys can give the hands-on on VS Code also. So what we will be doing, let's go to the coding part, guys. Okay guys, so now we are just moving to the Leetcode for solving problems and stuffs like that. So let's me just switch to the Leetcode. So here, remember one thing, that if my low is equal to 0 and high will be equal to the length of this particular array which I am drawing right now, the length of this particular array, here the start will be here and my high, or you can say my end pointer, will be over here. Okay, so I'm just writing low so that you can understand this thing as well. So what we are just doing, when we just write as low here 1 2 3 4, and we are just doing the indexing, so this 4 will be my highest, right? So it is nothing but the length of array minus 1. So my high will be nothing but the length of array minus 1. Okay, so now we have just understood the basic logic of binary search. So now we'll just try to implement this thing in Leetcode, because we just discussed to solve one of the finest problem on the internet platforms. We are just switching it to that. So let me just go further, and remember one thing, that when my low is lesser than or equal to high, we will run this particular loop. So this will be my looping condition, that if my low is on the less one, it should be lesser than or equal to the high. That in that particular case, my binary search loop will be running. So now we'll just go and we'll just try to implement this logic. But before that, understand these two things, that my mid will be calculated as low plus high plus divided by the 2. So like this, we'll be doing this stuff. So now let's move further and let's see. Okay, so now let's go and let's doing this question. So here we are just going to the next stuff. Okay, so remember this thing again, that my low should be lesser than equal to high. Till then only this loop will be running. Okay, so now we will be in a position to solve this problem. we are in the position of solving this problem. So let's go and solve this one. Okay guys, so let's go. Okay, so now this is the Leetcode implementation of it. So let me just erase this thing and just try it for you guys. I will just erase this completely and I will just try to write it again for you all guys. So I will just assign the low value as 0 and high value will be the nums, the length of nums minus 1. Is it okay? We will just discuss this thing also, and now we will run the while loop. Like when my low is lesser than equal to the high, we will run this loop. And in this particular case, what we'll be doing, simply guys, we know that we have to just compare. We have just done this step. Now we'll just comparing the target. So now we'll write one, first of all find the mid, because we will have to find the mid again and again. So mid will be nothing but the low plus high and floor division of 2. Now we'll be checking, like if my mid is lesser than target, then what I will be doing, simply be shifting the low to the mid plus 1. Okay, and then in the next case, now if my mid is, or we can say if my mid is, or my target is greater than mid, then what I will be doing, simply the high, if my target is lesser than the mid, then I will be shifting the high to the 1 mid minus 1, and else we will be returning the mid else. Okay, so now if this thing never happens, then I will be returning the 1. Simply we'll run this code and we will just see that this code is getting some sort of error. Let me see where I just done the mistake. So there is a mistake in this. Instead of this mid, I will have to add this mid in the nums array, because I have to find the value of that array, not the index of it. So like this, we will be doing the steps of binary search, and when you're going to run this, you will get a fine answer, and this code will be exceeded. Again, the time limit exceed problem. So here the problem lies here, because we are just, okay, so here I just make an error in the code. Now let's see if it's gonna work. So now great guys, it's accepted. So it means that we have done this problem in no time, and this particular case also accepted. So it's very much great to have you all guys in this particular video. In the next video, we will be talking about some sort of great problems in the binary search. Till then, stay safe, stay healthy. This is Ashwadan, and you are awesome. Shining off. So hey guys, welcome back to one more video, and today's video will be completely based on the binary search problems. So this is the day 9, and we have just merged day 8 and day 9, so that we can provide you one of the best crash course on binary search. So in this particular part of the video, or in this particular part of this lecture, we're going to talk about some sort of problems which we are normally asked in the interview problems, and these problems will be based on the binary search and how you can apply the binary search method to find out the solution of it. So keeping our tradition to solve the problems on the competitive platform, we have chosen Leetcode for this today, and the problem which we gonna solve today is named as find maximum in the sorted array. Okay, so we have to find maximum in, now there is a twist, it's not a sorted array, it's a rotated sorted array. So those who are new to the term like rotation, like what is this rotated means, what this actually thinks. So I will just give you the brief idea of 1 minute. In 1 to 2 minutes, I will just tell you the brief of rotation, and those who want to explore this thing in a more detailed way, they can just watch my arrays crash course. There you will learn about the rotation in a very detailed way. Just solve the problems on Leetcode also related to this rotation. So the link will be in the top on the I button. You can see there is the link, and I will also give the link in the description, and you can just watch the arrays crash course first, so that you can just get an idea like what rotation is. Okay, so let me tell you what the rotation is first. So what you have to do in this problem, I will tell you. So after this particular segment of this video, you will be able to solve this problem. So let me just go to the screen and let me just tell you what this actually rotation means first of all. So talking about the term rotation, so rotation is nothing guys, it is nothing. You can understand rotation in a way like, suppose you have given one array like 4, 3, 2, 1, 5, 6 and 7. Let me take this example. Like you have given this array. Now talking about this rotation, okay, first of all, it's not like this, it is like this, so that I can just help you to understand. When I say k is equal to 1 or my rotation equal to 1, then what will happen? This particular term will come in the front. So 7, 4, 3, 2, 1, 5, 6. So this is the array after one rotation. Talking about the second rotation, then this 6 will come again in the front. 6, 7, 4, 3, 2, 1 and 5. This is when k is equal to 2. when your number of rotations are 2. Correct? This you have understood like what rotation is. So this is the basic funda of rotation. When you will increase the value of k, similarly your elements will go one by one in the front and your rotation k will be incremented. Got my thing? What rotation is actually? Now fine, we have understood what rotation is. Now we will talk about the concepts of rotation in a very great way as possible. How this problem or how this particular concept contributes to our problem. So our problem name is we have to find maximum or in the sorted array. Okay, so we have to find the not the maximum, we have to find the minimum. I've written the wrong statement. I have to find the minimum in this rotated array. So what will be happening? What will happen? Like you can understand here, like suppose this is the array which is given to me. Let me just rough this. Okay, so this array, suppose we take an example of this array, any array like which is sorted. This is the sorted array. Now if I do 2 rotations here, then what will happen? If I do 2 rotations here guys, then this 6 will come here and then this 5 will come. Okay, let me take like after 1 rotation it will look like this. What I told that I have to do the 2 rotations, then this 5 will come again here. Okay, so this is the array which I got after the rotation and number of rotation is 2. After 2 rotation I got this array. Okay, now what I have to do? Now guys understand the concept over here. Now what I have to do? Now I have to find the minimum element in this particular array. So this will be as an input given to you and you have to find the minimum number in this array. So how you will do it? How you will find the minimum number in it? So firstly, if I tell you are not allowed to use the functions like min directly on this array. You cannot write like min this array. No, you cannot use this. You have to implement this thing. You have to use binary search here. Okay, by using the binary search you have to solve this problem. So how your approach will look like I am giving you 2 to 3 minutes, okay, or 1 minute. You can just pause this video, you can just try to find out the approach how to do this. So this is the problem. You are given this array and you have to find the minimum element of it. Now remember one thing guys, those who are new to this and those who just understand the concepts of this, otherwise you can go the previous part of this video and you can understand like where the binary search will be applied. Okay, so talking about the binary search methodology, what is the role of binary search? First of all, binary search always apply to the sorted array. This is its condition 1. You can apply binary search to the sorted array only. Second thing which I will make you clear, very much clear guys, which is binary search actually help to split the array. Okay, we can split the array by using the binary search. So like these 2 things you have to keep in your mind while solving this problem. So it will be very easy for you guys to understand it in a very great way as possible. So like this, I just given you the idea like what you have to do. You will be given this array and you have to find the minimum element of it. Very much simple. Like I can understand it, like my minimum element is here is 0. I can see it directly, but I have to do this by using the binary search. Okay, so talking about the test cases which is given to us, let's talk about the test cases first. So talking about the test case 1, so my test case 1, the array which is given to me is nothing, but you can just see the array which is given to me is 3, 4, 5, 1, 2 and my output is coming 1 as sure because 1 is the minimum here. So how we will write the binary search for this? So if you guys have tried yourself, now I will come to the approach. Okay, so let's first briefly understand this thing, what is happening. So when I apply binary search, first of all my binary search is only applicable to the sorted array. Okay, so but this array is not sorted. So let's suppose I take a low pointer here and high pointer here, because this is the basic like what we do in binary search. Okay, we have taken one low pointer and we have taken one high pointer. Now low pointer is on 0th index. Let me write index also, so it will be very much easy for those who are beginner also. Okay, so my low is on the first and my high is on the end. Now first what we do in binary search, we compare low and high, but before that what I will do, I will just calculate the mid. Now my mid is nothing but low plus high divided by 2. So when I will do this, I will get 4 by 2, which is equal to 2. So my mid pointer will be here at 2. Correct? This thing you have understood. This thing you have understood. Now understand this thing. Now understand this thing. This is the basic thing, which a basic terminology, or if a basic approach we use in a binary search, then this will come to your mind. Okay, this will definitely come to your mind. Now remember one thing here. Talking about this test case individually. So if I split this array into two, if I split this array into this, okay, or this, then remember one thing. Here, if I split this array, if I talk about this, or you can just understand in a way that here this array is the sorted array, and this array is also sorted. You can understand, like 3 is here, 4 is here, 5 is also here, right? So here there can be case that my elements, this element belongs to this sorted array or this sorted array. Got my point? What I mean to say, that in the first case, if I take an example of mid here, then it's very much clear that if my mid here, what I will compare, like if my mid is greater than low, first of all, okay, or what I can do, simply compare the low. If I compare this number with this number, and if this low is lesser than mid, then what I can say, if my low is lesser than mid, then it's very much clear, guys, that we are in a sorted array. Okay, this is the case when you are in the sorted array, because my low is lesser than mid. First of all, got my point? Easy. Now if my low is greater than mid, then it means we are in an unsorted array. Like I am talking about this particular case. Okay, I am talking about this particular case. So what will happen? Like you have just understood two things here. So what I am doing here in this case, what I will get? Simply guys, what I am doing here, if my low is lesser than mid, here 3 is lesser than 5, then what I am doing, I am just shifting my low pointer to the mid plus 1. Okay, but here guys, why I am doing this, because it can be a case that if I have written minimum as 3 first, and when I will check for low plus 1 here, I am getting 1, so this will be changed to 1. Got my point? And my new minimum value will be 1. It's very much simple, guys, to be understood. I am just trying to make you understand in a very easy way. Okay, so again let's see what we are doing. What I am doing, guys, simply I am comparing this number with the mid. Okay, my mid is 5 and my low is 3. If my mid value is higher or greater than 3, which you can see, or what I can say, if my mid is greater than low, then what I have to do? Simple. I have to first assign the minimum value as low. I am writing here in a very easy way. Let's see, this particular array I will write, or this particular test case I will be writing 3, 4, 5, 1 and 2. Okay, this is the case, okay, which I am writing 0, 1, 2, 3 and 4. Low is here and my high is also here. Got my point? Okay, now understand this thing. Okay, first what I am doing, I am calculating the mid. So I am writing here, first we are calculating mid. Next what we will be doing, we will comparing the low. So we will compare the low with the mid. Okay, and while we are doing the comparison, if my low value is greater than mid, so it means we are in an unsorted array, first of all. Okay, now if we are in the unsorted array, if my low is greater than mid, now in this case it is not. So let me talk about the case of this. Here my mid is lesser than, here my low is lesser than mid, because my 3 is lesser than 5. So in this particular case, what I will be doing? In this case, what I will be doing? I will declare one variable as minimum here as 0 first. Okay. So whenever my low will be lesser than mid, what I will be doing? I will be changing this min to the low. First, understand this thing. My low is changed to, or my minimum is changed to the low value. Okay. Here my low is 3. So what will be happening? My minimum will be changed to 3. Easy. Till here you have understood. And then what I will do? I will shift the low pointer to the mid plus 1. So what it means that from here my low pointer will move to here. Simple. And then what we will do? Again, if I will calculate the mid of this, like 3 plus 4 by 7, then it will be giving me 3. So it means where we will be? Okay, not 7, 2. It will be giving me 3. Okay, so where I will be? So my mid pointer will be at here again. Got my point? And what I will do? We will be comparing. So we know we will be adding here equal to now. Now there will be an equal to sign. So what is happening here? My low and mid are at same one. Then what I will be doing? I will be checking this minimum value. I will check this particular variable with this particular value, or how I can write this now. I will be checking the minimum of low and previously written min, which is this. Easy. So in this particular case, I will be comparing this 3 with this 1. So if this 3 or if this minimum is greater than this particular thing, then what I will be changing it to 1. Okay, easy guys, easy. And after that we will be shifting our low to mid plus 1. So my low will be over here. Here also you can check, but there is no use. So what will happen? The loop will go on, a loop will be completed, and I will get my minimum value as 1. 1 is my answer. Okay, so my minimum value will be 1 as an answer. So I got my answer in a very easy way. Okay, so it's easy. For this particular case, you understood the thing. Now let's talk about next case. Talking about test case 2. After discussing all test cases, we will be writing the code. But before that, all the test case should be very much clear to you. Okay, so talking about the next test case which we are having. So your next test case looks like this: 4, 5, 6, 7, 0, 1 and 2. So this is the test cases. Okay, so now what we'll be doing in this? What will be our thought process over this question? So what will be happening? We will just first write the index so that it will be easy for you to understand the concepts. Okay, so like this we have written the indexes. Now guys, what I will be doing? Again, I will be doing the same thing. Low will be over here and high will be over here. So first what I will be calculating? First we will be calculating the mid. Again we will be calculating the mid first. So here my mid will be over this. Okay, like 0 plus 6, 1, 2. How we can calculate the mid? Mid is calculated as low plus high by 2. So here my low is 0 and my high is 6th index. 0 plus 6 by 2, which will be returning me 3. Got my thing? How will we be calculating this thing? Okay, so this thing you have understood. Okay, how to calculate mid. This we have already discussed before. Now let's move further. Now what will we be doing? Now we will be comparing this particular thing first with this. Okay, so second we will be comparing what? Low and mid. So let's talk. Is my low is greater than mid or my low is lesser than mid? This particular case is or equal to is possible. Okay, let's understand this thing. So if my low is greater than mid, here if my low is greater than mid, then it means it's an unsorted array. But here my low is lesser than mid. Okay, so this particular case, we are dealing with this particular case now. So what will what will happen, we will create one minimum variable. Let me talk minimum variable and assign the value 0. So here what we'll be doing, we will again do the same thing, minimum, okay, and we will be adding the value of this low, and then I will be updating this low value, and this low will come to mid plus 1. Easy. So this particular will be moving to, so this particular low will move to this now. Okay, easy. Now again what we'll check, again we will calculate first the mid. Again what we'll be doing, we will be calculating the mid. So when we will be calculating the mid will come now here. This will be mid at 1. Again we will be comparing this mid and low. Okay, this mid and low. Again we will be doing the same thing. We will be comparing. Then what will happen? Again what will happen? Now again my low is lesser than or equal to mid. Then what will happen? Now I will check this low value again. Now this low value will be checked with the previously assigned minimum value. So here my previously assigned minimum value is 4 because we have just assigned this value here. Okay, and then when we will check, so we will notice that previously assigned value is actually greater than this particular 0, which is low current value. So this particular value will be changed to 0. Easy. So how will we be doing it? Simply we will write here min of minimum and low. Easy. Like this we will be comparing this thing with the previous value, and after this particular thing, after this particular iteration, what will again will happen? Again now my pointers will look like this, that my high pointer will be here at 2 only, but my low pointer which was previously here will be now at this particular point. Okay, at this particular point, and my high mid pointer will be also here at 2. And we all know that when we will just compare this to, when we will just compare with 2 with this particular 0, and we all know that 0 is actually lesser than 2, so it will be remaining 0 only, and we will return the minimum. So in this particular case 2 will be my answer again. Oh sorry, 0 will be my answer again. Okay, because this is the minimum. So got my point, guys? Got my point? How will be doing it? 2 test cases you have seen. Let's see one more test cases, and this will be the final one. So talking about test case 3 or solving this problem, how we can do it. Okay, so my third test case looks like I have given one number like 11, 13, 15 and 17. Okay, so let me not take this test case, let me take one different test case as whole. Okay, I will take one test case which was slightly different. Let me take a case where the things look like this. So this is an interesting test case. Okay, first of all, let me tell you, this is an interesting test case. So now there will be a change. Now, firstly what we will do, we will write low here, we will write high here. When we will calculate the mid, so it will turn out to be this particular thing. Like, because we all know 5 by 2 will be returning me as 2 point something, 2.5. So we will write it as a 2, as a float. Okay, so this will be at here. So my mid is at 2 right now. So first what we will be doing, we are calculating the mid, which we have already done. Next what we will be doing now, I will be comparing my mid with the low. So here you will notice that my low, now here my low is actually greater than mid. Then what we will be doing. This is an interesting case now, because till now what we are seeing where my low is lesser than actually mid. So now here what will flow will be looks like. Now what's the flow? Because the flow will be completely different here. Okay, so the flow will be completely different. Flow will be completely different. So how will we just solving this? How will we doing it? Because here you can understand this thing. Now what I will be doing? Just understand the case here. Now in this particular case we will be just changing the value of high first. Okay, what we will do, we will change the value of high to where, to what perspective, or to where we will change the value of high. We will change the value of high to mid minus 1 first of all. So this high will be moving to here. Easy guys, understanding this particular test case now. Now what we'll be doing, now we have just changed it, and then what we'll be doing, because we know that my mid is actually lesser than low. So what it means, so it means that my array is not sorted here. So what I have to do, firstly in the minimum I will write the mid. Simple. In the minimum I will write the mid. I have assigned one minimum variable and given the value 0 till now. So what we will be doing here, firstly we have just checked low and mid. So if my low is greater than mid, we have changed the value of high. My high is now here, and then my minimum is mid till now. Easy. Now what I will be doing, now let's understand the case what I am doing. So now guys, what we will be doing, simply in the next iteration, what we will be checking and what we will be doing, again we will be calculating the mid. So now my mid will be this. When I will check again here, till now my mid value or the minimum value is, you can understand that here my minimum value is, like when I just assign the minimum value as mid and the first, so my min is now 6. Now I will check again, because my high moves here, my high pointer is here, and when we will calculate the mid again, then my mid will come over this particular case or the 7. Now guys, it's very clear. We will again check for the 7 to be the same, but what will happen, they will not be the same. Now the case is, now here we will in a case where my mid and high will be on the same point. Okay, my mid here and my high, like you can understand, right now my high is on the 1 and my low is on this, and my mid is also on this particular point. So now this is the case where my mid is lesser than or equal to mid. Then what will we do? Now this is the case, because from this particular thing, now this flow moves to here, because my mid and low is on the same part. Okay, they are on the same point. So what we will be doing, again we will be doing the same stuff. First we will writing minimum as low. We will be comparing like here. So you will notice that the 6 already, so we will not change the value. Okay, here is the minimum of low comma minimum. This is minimum, this is the min. They both are same variable names. Okay, we will checking this, and what we will be doing, we will changing our low to mid plus 1. Easy, got the point? This thing like this we will be doing. Okay, like this we are changing it to mid plus 1. So it means now my low pointer will be here at high. Okay, so my low and high is now on the same point. My low is also on this particular one, and my high is also on 1. Both are on the same. My low is also on 1 and my high is also on 1. They both are on the 1. Now what will happen? Again the loop will run. Let me erase now. Till now you have just understood the working. Okay, so again now my low and high is here, so it means that my mid will also be here. So now what we will doing again, here this case will be called, and we will check for the minimum. So now my minimum value will be changed to 1 in this test case. Okay, and then what will happen, this particular thing or this low will move, this low will also move. Like here you can see that what is happening. Again we are comparing the low and high, or no, low and mid, and they calls out to be the same. Then what is happening, we are changing the minimum value again, to the 1. Okay, and then my low will be again mid plus 1. So now my low will move to this. So like this we will be just doing the things, and we will be calling this till we reach here, and here we will reach and we will get the value as 0. Okay, So here we will be get the value as 0. Easy guys, understood this problem what we are just doing it. Okay, so this is the case we will be getting the value as 0. Like this we will be moving towards this particular direction. From here we will be moving to here again and again recursively. We just got our answer. So I think it's clear to you how we just want to implement this thing now. So now what we will be doing, now let's talk about the code part of it. So firstly we will declare one answer, and just we will give the answer value as, you can understand of a case, we will give the answer as 0. My low will be at 0 initially, and my high will be at length of nums minus 1, because nums is the array name. This is the array name or the list name. Okay, this is the case. Now I will be running one while loop which will run till my low is lesser than equal to high. Then what I will be doing, I will be calculating the mid, which is low plus high. So I will get the mid here, and then what I will be doing, then I will be checking for the condition, like if my nums of mid, because I have to check the mid value. So if my nums of mid is lesser than, okay, is lesser than nums of low, because you have to compare, we have just seen here this particular case above. Okay, this particular case, like if my low value is lesser than to the mid, then what I have to do, I have to just assign it to the minimum variable and just compare it with the previously assigned value, and then I have to just shift the pointer of low. So here if my low, okay, but here what is the case, here we are writing like if my mid is lesser than, like you can understand here, this is the example which we have just seen above. Here if my low is now greater than mid, then I have to do this particular stuff. So what I will do, simple, I will write this case like I have to just change the high to mid minus 1, and then I have to change my answer to minimum Here what we are doing, here again what we are doing, simply guys, simple, just what we are doing, simple, we are just writing here answer of nums, and for what value we will be comparing, with the mid value. Easy, with the mid value will be assigning. Okay, where will be my mid value, that I will be assigning to the answer. Okay, this you have understood. Else, now in the else case we are considering both lesser than and equal to cases. Like in the else we will write this particular thing. What is the thing, we have to first write the minimum. So my minimum, or I can write like my answer will be, if this particular, then I will be writing the answer as here nums of, not mid, low will be my answer, because my low is lesser than mid. This particular case we are writing in the else, where my low is lesser than mid. So this is the case, and then what we will be doing, we will be changing our high pointer, we will be changing our, not high pointer, we will be changing our low pointer to the mid plus 1, and then I will be returning my answer. Simple code guys, simple code, this we have to just implement. So let me implement this particular thing one by one. We will gonna implement this thing. So let me now shift to the next window and let me see how we can do it. So this is the implementation part. Now we will be doing it here on the Leetcode, and let's see how it will work. So I have explained you the basics. I have explained you the basics in a very easy way as possible. Now we're just gonna implement it. Okay. So how will we be doing it? Firstly, we will write here that we have given the nums as an array. So first I want to declare an answer. Just see the below, there is a concept of the approach which is, there is a approach which is showing here at down. Just see it. Okay, so first we have just written the answer as 0, and then we have to assign the low as 0, and then high will be the length of, okay, like till my while low is lesser than equal to high, what you have to do, you have to first calculate the mid, which is nothing but the low plus high. Okay, then if then if my first condition, which is my first condition, this is my first condition, okay, like if nums of mid is lesser than nums of low. So in that particular case, what I have to do, if this particular things happen, then what I have to do, I have to simply change the high to mid minus 1, and then what I have to do, then I have to change my answer to the minimum of, I have to calculate this thing and the mid. Easy. And if this thing not happens, then what I have to do, simply I have to write my answer as minimum of answer. Here will be the low, not like this, it will be nums of row, because we want the value, not the index. Okay, like this we will write, and then we'll be returning the answer. Easy. You will run it. Let's see how it will be giving me the answer. So okay, so it's giving me the error of time limit exceeded. Why this thing is coming, let me tell you, because we forgot to change the low pointer here. Okay, so here my new low pointer will be mid plus 1. This particular thing we have forgotten, and because of that we got TLE or runtime error. So what this time limit exceed TLE means, it means that your pointer is going out of this particular array. Okay, so this, remember this thing, if this thing happens, so it means that your pointer is going outside this array. Remember this particular thing. Okay, in future it will be useful for you when you will get TLE or runtime errors like this. So it's coming here. Let's see what errors you are getting. So we are getting the errors here. Okay, so let me check the implementation part, like what we have just mistaken. So what's the mistakes which we have done? Okay guys, so in the answer, the problem is, like when we talk about the arrays like this, okay, when we talk about this particular arrays, let me talk this particular case. Okay, so here what will be the case, this is the minimum, and if we say, like if this thing is also not minimum, okay, let me talk like this thing is also not minimum. Okay, so here what will be the case, my answer is assigned to 0, so this thing is actually greater than minus 1, right? So it will never take this particular thing. So what I have to do, basically, simply I will just write the maximum of nums. Instead of anything, I will take the maximum of nums here and just run it, and then you will just able to see we got accepted, because instead of taking a very least value or the minimum value, we will take the maximum value here, and then you will see we will able to run it in a very no time as possible. So now I think you understood this problem, how this problem looks like. So easily guys, you can do this problem you can just figure it out. You can just watch this video again at some particular point steps, because this problem is really important when it's come to the interviews part. So till then guys, enjoy this thing. I hope you are enjoying this series of this particular video or binary search crash course, and we'll just see in the next segment of this thing. So let's move to the next segment. Okay, so hey guys, welcome back to the one more problem of the binary search today. And today this problem is a very interesting one, and in this problem we have to find the row with the maximum number of ones in this, and this is the most important problem when it comes to the interviews, and it will help you to understand binary search in a great way as possible. So coming to the problem, let's understand what the problem is right now. So here the problem statement is given to us. So we have to find the row with the maximum number of ones, and problem we are given with the 2D matrix. We are given a 2D matrix. So I'm just underlining the important words over here. So we have given a 2D matrix. That's an important point to be noticed, because 2D matrix is nothing but it is just you can just take an example of a list inside a list. 2D matrix, we have already discussed about matrix video, which is the link will be in the description. You can just go and watch this video also. You all know what matrix is, so let me just tell you. We have given one 2D matrix. Suppose when we draw it, I think you will understand. This thing is a 2D matrix. Like take example, this 3 is the it's a basic matrix. So like this you can understand what 2D matrix is. I've just drawn here, you can just understand it. Like this thing is the basic 2D matrix. So according to this problem, we have given one 2D matrix to us. Okay, now talking about containing the binary digits, and each row is sorted. So this is the important condition again. So what they are just trying to tell, like this matrix which is given to us only contains binary values. First of all, remember this thing, only contain binary values, and it means if it contains only the binary values, then the values possible which can be there is nothing but your 0 and 1. These two are the possible values. Okay, these two values are possible only when it comes to checking. And the next thing is, like, it is telling me like this matrix contains binary values and each row is sorted. Each row is sorted. And if I say this, like my each row is sorted, so what it's mean actually? So it means that when I talking about the row like this, if I take example of this, like this, you can understand of a problem. Here what is happening here? This matrix contains only the binary values. It contains only the values, and the thing is, like if I take this row, then it is sorted. Okay, if I take this row also, it is also sorted. If I also take this row, then this is also sorted, and if I take this also, it is also sorted. So my each row is sorted one. This problem is telling me like that. Okay, now let's see here. So what I have to find? So what's my problem now? So here I have to find, I have to find the row which contains maximum number of ones. Okay, so like this we have to find. So we have to find a row like this. We can see here, like there are two rows which contain the same element. So I will be giving me the answer like this. So I have to find that row which contains maximum number of ones. This row contains 3 1, this row contains 4 ones, this row contains 1, this is also 4. So I will be returning this, but it's contained at the least index. So like this I have to return my answer. So I have to return that row which is containing the maximum number of ones. So easy guys. I think you have just understood of this problem. Till now I think you are pretty much clear with this problem, what this problem actually looks like. Let me mute my phone. Okay, so now let me move further. Let's move further. Okay, so now let's understand this problem even more in a more detail. So let's go on the understanding part now. Okay, so what I will be doing here, simple guys, don't make it complicated. It's an easy problem to be understood. So what I have given one, let's take one row. Okay, let's take one row. Let's take this top row. I will be taking this top row first. Okay, I will be taking this row first. Okay, so let me take this row here. I have taken this row, and this is nothing but your 0 0 1 1 and 1. Simple. So I have taken this particular row. Now how will we be doing? So we have to do this by using the binary search first of all. So we will be implementing the binary search here, and by using that binary search you will be finding the answer. So let's take a case. Suppose my low pointer is here and high pointer is here. So it means that my mid pointer is here. So I will search, first of all I will search 1 here. Okay, so how we will search? We will check that is my mid is equal to target. So yes, it is equal to the target. So what we will do, we will be returning this index, and this index is 0 1 2 3 4, and this will be 2. So 2 will be my answer. So from 2 I will be getting the first index. So I have to get first of all the first index, because we know this thing that this array is sorted. So if I found the first appearance of 1, so I just have to find a position where my 1 is occurring the first. Here my 1 is occurred first time, so I have to find this particular location. So in this particular case I will get my 2, which is answer is correct. But let me take of a case, let me thought of a case where it is written like this. Yes, like this. Here how you will do. Here I will be doing, like you know that my low is here and my high is here. It means that my mid will be here. So if I will check for 1 here, so it will be returning me 2, but it is not correct because here also 1 is there. So I have to find the first time 1 appeared in this particular array. So my first is here. So instead of returning the mid, what we will do? So instead of returning the mid, what we will do? We will shift our high pointer to this particular thing. Okay. Why we are just doing it? Because we are not sure. Like this thing we know that if this thing is 1, if mid is 1, then it means that till the end of the array we will get 1 because this is sorted. This array is sorted. So what we have to check? We have to check that whether before this one is 1 appeared or not. So here we know that 1 appeared. But how we will check this? So instead of returning the mid, which we have just done in the previous case, we will change our high pointer to mid -1, and by using this, what will happen? This particular high will move to this position. So now my high will be pointing, let me tell you. So my high will be here now. Easy guys, easy. Now my high will be here. So at that particular time period, we will get our answer because we know this thing, when my high will be here and when I will calculate the mid this time. So mid will be my 1. So not my 1. Let me tell you again. If I calculate the mid 0, 1, 2, 3, 4. So 0 plus 1 upon 2, I will be getting 0.5. So my mid will be right now here. And when my mid will be here, I will compare it with the value. And we will shift the low over here. So here I will get my 1. So I will be returning the low. Simple answer, we will be returning the low in this case because we will move the low shifting like here. So the case why we are doing this, because we are sure that if I take this case again, we are sure that if this thing is mid and if this thing is equal to 1, so we know this, like from here to here till the end, there will be only 1, there will be no 0 because this array is sorted. But when we talk about the previous case, so from before this 1, we will have to check like whether 1 appears or not, because we have to find the first time 1 appeared. So here this thing is appeared. So we will write the index like 0, 1, 2, 3, 4, 5. So at particular 3, till now I know this like my first appear here. But when I will check, I will move the high pointer here and low pointer here. So I will check for this particular thing, and if I will found that in this particular array where the first appears, and if the first appears here, if there will be a 1, then we will just returning that particular index because this is the first time in this particular array. This is the place where 1 appeared first. And when I will get the location, so in that case what will be location I will be getting? So in that particular case the location is 0, 1, 2, 3, 4. This particular I will be returning 1 as an answer. So 1 is the answer which will be returning. Now what I have to do? I will subtract this 1. From the length of this array. Okay, so length of this array minus this particular 1. So what I will get? Suppose this contains 5 minus 1 is equal to 4, and you know that there are only 4 ones. So I will get a count of 1 in a particular array by using this. So what we have done till now, let's understand this thing again guys. We have taken one array. We have written low here. We have taken high here. When we will calculate the mid will be here. Then what we will be doing? Then what we will be doing? We will checking like is this thing or is my mid is equal to the target. So in this case it is equal to the target. Then what we will be doing? We will check like in this particular array is 1 appears or not. So for that thing, what I will do, I will shift my high pointer over here. Okay, so my high will be mid minus 1. And then I will check, like if my 1 appears in this array, then I will return that particular index. So in this case, 1 will be my answer, which will be returning from that complete binary search. So in that complete binary search, 1 will be my answer, which I will be returning. And then I will calculate the length of this array. So the length of this particular array, which we have just done, it comes out to be the 5, because 1, 2, 3, 4 and 5 elements are there. So 5 is there. So when I will be subtracting this 5 from this particular index which I am getting, I will get 4. So there are 4 ones, we know. So like this we will be getting the count, like how many ones are there in that particular array. So like this I will be getting the count, and after getting the count, what I will be doing? After getting the count, I will be storing this count in a variable. Let's say here I just got a count of 4. Now what we will do, we will run a loop. We will run a loop in a matrix, and for that particular matrix we will compare the count with other values of the rows. Now we will check for different rows, and we will compare their count with this global value, and then we will get our answers. How we will compare it? I will write here the maximum. So from where I will find the maximum? The length of I have to find this. So instead of this, how I will write, like we know that from this I will get the count of maximum. Now I have to return that particular row which contain maximum number of ones. So it's very much simple. From the row from which we will get the maximum count, that row will be returning. That row we have to return. So it means that if this array, I consider this particular array, let's take this particular array 0 0 1 1 1 0 1 0 1 1. No, not like that. We have to take the sorted one only. So let's take this and let's write this. Not like this. We will write it like 0 0 1 1. Let me do this. Okay. So now if you see this example clearly, if we will run our binary search on this, and then we will subtract the length, I will get the answer 3 here. Okay. So initially my count will be 3. Now I will count this particular thing. So here my count comes out to be 2. I will compare it with the 3. So till now 3 is the maximum, so this value will not be changed. Here my count will be equal to 4, not 4. Here my answer will be 4. Now I will compare this 4 with the 3, and we know that 4 is greater than 3. So we will change this 3 to 4. Now we will compare this thing here 1. Now we will compare it with this particular count, and here we know that it's not 4. It will be 4 only. It will not be changed to 1 because 1 is lesser than 4. Now we will be returning, if we write the index of this, so we will be returning this particular answer. So my output will be 2, because 2 contains maximum number of ones. Okay. So now how we will be doing this? So what we will be doing now, how the code looks like. First of all, we have to write our traditional binary search code. But there will be a one difference in the binary search. Like now when my target is actually lesser than or equal to the value, okay, lesser than or equal to the mid, if I write it here mid. So in that particular case, what I have to do, instead of returning, or instead of just taking the shifting part, what I will do, simple guys, what we will do, we will just shift our high pointer -1, and as things follows. So let me comes to the code approach here, and let me see how we can just do it. So now we'll do the coding part of it. So it's very much simple, don't get hesitate of it. We will just go to the coding part. So here we are in our coding part, and let me just okay, this will be the last screen, and we know the stuffs. Okay, now we will see this thing again. So what we'll be seeing, like I will just change this thing to this particular setup. Okay, so now I've already taken an particular thing for you. I will just I've taken one matrix, and this matrix is nothing but it looks like this. It's look like 0 0 1 1 1 0 1 1 1 1 1 1 1 1 1 and 0 0 0 0 1. So this is the matrix. So from this particular case, we all know the answer. We all know that the answer will be this. So the final answer will be 0 1 2 3. So answer comes out to be the 2. So how we'll find this answer first of all? Okay, so this matrix is given to us. Now we'll write a binary search code. So how we will write a binary search code, guys? Simple. We will just call the binary search. So from I will create one function like def binary search. So this is the functional programming I am doing. So what it will gonna take? This will take the array, and it will take the start, it will take the end, and then it will be taking me the target that to be searched here. Okay, simple. This is the basic thing which binary search takes. I hope that you all understand this thing. Okay, now let's see how we'll do. Now we will calculate. First of all, we will write a loop while start is, if I take high and low pointer, then it will be more easy for you also to understand. So when my low is lesser than and equal to high, till this particular case you have to run the loop. So in that particular case, what I have to check, I will check that if my array of mid, first of all I will calculate the mid also here. So my mid will be nothing but the low plus high floor division of 2. So what I will check that if my array of mid, what I will check, we will write one pointer here low, we will write one high here, my mid will be over here. I will check if this thing is equal to the target or not. So simply what I will check that if this mid is also lesser than the target, lesser than or equal to, I will write the target. Then what to do? Then what you have to do, if this mid, let me take that greater one, like if this mid is greater than a target, which is never gonna happen. Let me talk about this particular case till now. So what will be the condition we'll be writing finally? So we'll be writing a condition which will looks like that if my this mid is lesser than or equal to target, then what you have to do, simply here what we'll be doing, we will shift the high to mid minus 1, because we know that if this thing is 1, then now we will have to check in this particular array, because we know that we have to check for the first occurrence. Okay, for the first occurrence. So here now my high will be over here. And we will be checking for the conditions. Now we'll be checking, and if anything not finds, then what I have to do, simply I will shift my low to mid plus 1. Okay, so I will just shift my low to mid plus 1, and at that particular case we will be returning the low, because we have already discussed that we will have to return a low when we were just talking about this particular scenario. Then we are just told then we will be returning the low, this thing here, this thing, all things will happen. Okay, got the point why we are just returning the low? Because here you will just see one point, that if this is the one which I got, and if I again calculate the mid, and if I got this particular thing as a 1, then I will have to return the index of it. So like this we will be tackling with this particular scenario situation. So now this we will be returning the mid. Now we will just gonna create one global variable which is count. Let's suppose this is count is 0, and let's create one index. Like we will have to store an index. If you don't want, you cannot, just chill it up, not problem. Now I will run a loop for I in range 0 till length of this particular a. Okay, so till this thing I will be running a loop. Easy guys, easy. 0 1 2 3. Okay, so 4 times is gonna run this loop. Okay, now what we'll be doing, now guys, now in the count, what I have to do, if I got, let's suppose again this case, like in this thing I will get my count as 3. Okay, I will get the count as 3. So how I will be getting this? And after this count as 3, I will compare if my initial count is 0, so I will be comparing the value with this. So how we will do it? We will use the max function. So in the max function, we will be taking two arguments. One is the count and next is the binary search. And in this, what I will be passing the value, first I will pass the array, which is my a, then my start, which is 0, and my end is length of, what's my end looks like, length of a minus 1, and then I have to write here 1 because I have to find the 1. Now remember one thing, if you will run this, you will get an error. Why? Because this a is your complete 2D array, but I want this particular row. Every time I want to run the binary search on a single row. So for that particular case, what I will be doing, I will be writing like this, I. Like this I will be doing it. Okay. So like this I will get the maximum count. But remember one thing, to get the maximum count, this code will be returning me the index. Okay, the first index. Here it will be returning me as 0, 1 and 2. But we want like how many times this one appears. So how we will do this? Simply we will do the length of a. We will write it like this. And here the length of a minus of binary search. And like this. So how we will be doing is, so here you can see that in this count we will be finding the maximum out of it. So if I print this, let me say that if I want to print this, and then what my count looks like. If I print my count over here, then what will happen? Let me just, so here it's 5. So it's pretty much clear that this thing is coming. So my count is coming as 5. But I want to return this particular index. Like here in this case we know that there are 4 ones, right? In this case here are 4 ones. So if I change the value of this matrix, even like this is 0, this is also 0, and then it is 0, and then it is 0, 0, 1, and if I run this, you will notice that I will get a 5 answer here. So it means that it's a code problem here, because 5 is not the correct answer which I should get. I should get a 4 answer here. So let me check the code and let's see. Here we are just given a right thing. Okay. Here the implementation part is correct. And then if I talk about the target comparison, we are also comparing the target over here and we are just shifting it the mid. This is also the correct. And talking about the else condition also correct because we are just doing the mid plus 1 and we are returning the low. So binary search is completely correct. Let's see now about this loop. So in this loop we are just running the loop still from 0 to length of a, and then in this particular loop we are just finding the maximum out of the count and length of a binary search. We are passing this particular thingy over here and we are just searching the one. So like this our implementation part is correct. Because we are just searching for the binary tree. Okay guys, so here we have made a mistake. Why? What is the mistake? When we will just compare the target, or we can also notice, like if this thing is the target, and if this comes out to be the same, or if this target is lesser than, if this thing is lesser than, like here if I take this array 0, 1, 1 and 1, and here is the target, here is the mid, and my target is 1, and if I compare this, so you'll notice if it comes out to be the same. But here if 0 happens here, so if this mid is here, so I will compare, like if my mid is lesser than the target, then what I will do, I will simply, if this thing happens, I will simply shift my low over here. So for this we have written the else statement, but for this condition, when this thing is greater than the target, if my mid is greater than the target, we know that in binary search what we do. So if my mid is greater than the target, like here I will write the array of mid, and in this particular case we will be returning the high. So let me check again. Yeah, correct. We have got the answer 4. So it means that we are just getting the correct count over here. Now I have to return the index. How we can do it? So what we can do, let's create one global variable which is 0, and let's create one index variable which is 0 again. Okay, and let me write this as a global this, Now instead of this max, what I will do, I will just take the value of count. Okay, I will just take the value of the count, and then what I will be doing, simply I will take the value and just compare the count with the value of the global. So if count turns out to be the greater than the global, then simply I will change the value of global to count, and then what I will be doing, I will be storing the index of I in it. Simple. And if something else happens, I will just pass, and just when I will print the index now, you will notice that I will get the 2, and we know 0 1 and 2, this thing has the maximum or the maximum number of 1 counts. So I think you understood this problem now, how we have just coded this problem, we just got our answer. I will just remove this particular window so that you can see. So here you see we have got our answer as 2. After running this successfully, got our answer 2. So I think this problem is now clear to you. What we have done, simply we have written the binary search away. Here we are just getting the value. Here we are getting the value. In the first iteration we will get the value as 3 over here, and we will just subtract this, like here 0 1 and 2 will be the answer of this, and the entire length is 5 minus 2 3, it means 3 ones are there. Similarly here what we will be getting, 0 1 2 and 3 will be getting 5 minus 3, it is 2, and we will comparing with this 3, the 3 will remain the greatest. Here we will just compare it, the 4 will be coming, but 4 is greater than the 3, then my global value will be changed to 4, and then if we will compare this thing, again it is 1, then it will compare to the 4 and it will be less, it will remain the 4. So like this it will be remaining the 4, and we will store the index it as 2, and we will be returning the index as 2 here. So now you can see we have to solve this problem. So you understood this problem. So I hope you like this particular crash course on binary search. So this is the output which you are getting. So I hope you like the course on binary search. We will soon meet you in some other problem as well, and we will solve many problems now. So till now, stay safe, stay healthy.